One thing I forgot to mention, so I'm adding it in here, it's this concept of isoelectronic species. What is that? An isoelectronic species are an atom and an ion, or two ions that have the exact same number of electrons and the exact same electron configuration. So for example, we're going to need the periodic table for this. So let's say we've got the atom neon. Neon has an electron configuration of 1s2, 2s2, 2p6. If you look at your periodic table, I need my glasses, neon's got 10 electrons, right? Because it's got 2 in the first shell, 8 in the second shell. So this is the electron configuration of neon, a total of 10 electrons. Now, let's take a look at the ion fluoride. So the fluoride ion, remember how we said that in order to fulfill the octet rules, the nonmetals gain electrons to look like the nearest noble gas. Well, fluorine is very close to neon. It's just one away from neon. So all it has to do is pick up one electron, and then it looks exactly like neon. So fluorine, normally its atomic number is 9, but if it picks up an electron, then instead of having 9 electrons, it now has 10 electrons. So the fluorine atom, fluorine, not fluoride, has 9 electrons. But if it picks up 1 electron, the fluoride ion has 10 electrons. Fluorine electron configuration is 1s2, 2s2, 2p5. Fluoride, negatively charged fluoride, its electron configuration is 1s2, 2s2, 2p6. So now take a look at neon with its 10 electrons and fluoride with its 10 electrons. That would be an isoelectronic species. An atom and an ion that have the exact same electron configuration and have the exact same number of electrons. All right, let's take a look at the oxide. I'm going to erase this over here. Let's take a look at oxide. Now, oxygen, just normal oxygen, has 8 electrons. Its electron configuration is 1s2, 2s2, 2p4. That's the electron configuration of just plain oxygen. But oxide, when it picks up 2 electrons to look like neon, remember what we did in the previous chapters, or actually in this chapter, but earlier in the earlier videos. In order for oxygen to fulfill the octet rule, it needs to pick up 2 electrons to look like neon. So if it picks up 2 electrons, the oxide ion now has 10 electrons. Its electron configuration looks just like neon, 1s2, 2s2, 2p6. So you can see that the oxide ion and the fluoride ion are an isoelectronic species. Oxide ion with neon, isoelectronic species. So you can create a whole series of things that are all isoelectronic with each other, so long as they have the exact same number of electrons and the exact same electron configuration. Okay, so I just wanted to make sure you had that in your notes, and you can move on to the next chapter.